I invite you to visit my poster. Thank you very much.
Okay, hello everyone. My name is Doris Saif from United Republic of Tanzania. Today I stand before you to give you an overview of my e-poster presentation, which focused on global appearance of radiocesium in IMA samples. And the major focus is for the stations located in African continent, European continent, and Asian continent. This has been achieved by ascertaining the trend of radiocesium before in a Fukushima accident. Okay, so also we performed a frequency comparison before in a Fukushima accident, and in addition to that, atmospheric transport modeling based on backward trajectory models has been performed to discern the possible source of emission in the selected stations. To learn more about this, please welcome to my poster in board number 4. Thank you.
Hello everybody, I'm Andrew Petts from Hartlepool Power Station in the UK, and I'm going to be talking about the xenon environmental nuclide analysis at Hartlepool collaboration, which is a sort of a unique collaboration involving academics from Sweden, America, the United States, the UK, and we work closely with the operator, EDF. And I'll be presenting the scientific objectives, sort of stack monitoring, remote detections from atmospheric transport, and sample measurements. So I'll be showing preliminary results we've obtained so far, which is basically stack measurements, at source measurements, and measurements of filtration media. So I'll be in the session tomorrow morning, Thursday at 9 o'clock in the morning for a poster session, and hope to see you there. Ask any questions. Thank you.
Yeah, good morning. I'm working at Korea Atomic Energy Research Institute. Radiological emergency preparedness system in Korea developed to predict the behavior of radionuclides released into environment and to estimate dose rate of humans for nuclear accident. This system is composed of 3 main models: atmospheric dispersion, marine dispersion, and dose assessment module. These 3 main models of system has already validated by model-to-model comparison and measurement for the Chernobyl and Fukushima accident. This system is based on the web. Users can access through increasing IP address, username, and password for security. This system is now operating for government and nuclear-related organization in Korea. Thank you.
Hello, thank you for being here today. As Dr. Kannawati mentioned on Monday morning during the high-level panel, it's important for the CTBTO to learn how to leverage global scale models, global scale data from the IMS into to inform smaller scales, regions that we might be interested in. And it has been proven that when a contaminant is released in a region that has complex terrain, the evolution of the dispersion of the contaminant can be dramatically different. Therefore, we build models in local scale which it's like 5 kilometers variation in the source of dispersion, and we inform with the hope of inform atmospheric transport model in order to have more accurate predictions. And I will be glad to have you by my poster tomorrow morning from 9:30 in screen number 6. Thank you so much.
Hi, this is Akshay Govardhan from Lawrence Livermore National Lab. So the work I'm going to talk about is radionuclides which are produced from underground nuclear explosion. These migrate slowly through the subsurface and eventually vent into the atmosphere, right? And from there, through the local winds in the atmosphere, it's transported to the detectors downwind. All these nuclear test sites are usually located in very remote areas and surrounded by complex terrains like hills, valleys. And to predict the transport of these radionuclides in this area, you need a model which can predict these features, right? Which can resolve these complicated features in these complex terrain area, because they're going to influence how the radionuclides is transported towards the detectors. So as a part of this work, we described efforts to validate such high-resolution, large eddy simulation atmospheric transport model, which can predict the transport of these radionuclides which are emanating from the subsurface, coming from an underground nuclear explosion. And we're going to show this work. So if you are interested, you can come visit us at screen 7 tomorrow morning at 9 o'clock, and I'll talk more about it there. Thank you.
Hello, good morning. I'm Alivia from Nuclear Energy Regulatory Agency of Indonesia. For today's occasion, I would like to present about our priority program right now, the Indonesian Radiation Detector Monitoring System, the IRDMS. The purpose of this system is to detect any radionuclide fallout that might arrive to Indonesia, come from nuclear power plant accident or military attack. So in this presentation, I would like to share focus on 5 detectors that we installed in CTBT station in Indonesia. There's a lot that we need to learn about this program, and I'm open to discussion, so please come to number 9. Thank you.
Hello, I'm Michael Mayer from PNNL, and today I'm going to talk about the detection and analysis of anomalous radioxenon isotopes. During phase 1 testing of the Xenon International system in Knoxville, Tennessee, the system detected anomalous radioxenon which has not been detected before. This includes Xenon 122, Xenon 125, 127, and 129M. 2 of these isotopes actually decay down into iodines, iodine 125 and iodine 122, which can remain in the detector after evacuation of the radioxenon. We came up with a method that uses abatement equations and the iodine counts for iodine 122 to determine the activity of these of the Xenon 122. If these radioxenons are present in this location, they can be present at other locations that can be either spallation neutron sources or medical isotope productions that utilize new radioxenons. If you have any questions about this presentation, please come see me at the poster presentation. Thank you very much.
Good morning, I'm Silvia Generoso from the French NDC at CEA. So in this study, we explored the benefits of ensemble meteorological data for the simulation of the industrial xenon background. We have quite a unique setup as we used real emissions from a facility located in Belgium, available with the STAX project. And we have Xenon-133 measurements at Paris location and and in Germany at the IMS station. And so both locations provide valuable insights to see concretely how this ensemble approach can help in the categorization of IMS radionuclide measurements. So if you want to see how ATM concretely performs with real emissions and probable meteorology, come and see the poster. And if you come, you'll be able also to play the game of the Xenon Quest. Thank you.
Good morning, everyone. I'm Eduardo Nasif from INVAP, Argentina. As part of the STAX initiative, we have installed a STAX, Novel Gas STAX Monitoring Unit with support of PNNL and National Atomic Energy Commission of Argentina at CEST Atomic Center, where the medicinal isotope production facility is located near Buenos Aires. This facility over there is responsible for the supply of radioisotopes for Argentina, completely part of the demand from Brazil and also for some South American countries. The STAX monitor is an equipment that is designed in order to target, to catch up with relatively high concentration emissions in terms of becquerel per cubic meter. So that means particularly for those isotope production plants with low dilution regime. That means relatively low flow rate. The equipment is already operating since for 1.5 years. And if you want to know details about the design, performance, capabilities, please visit tomorrow morning our poster in the P24 poster session, touchscreen number 12. Thank you very much.
Good morning, my name is Jolanta Kuśmierczyk-Michulec, I'm from CTBTO, and on behalf of my co-authors, I would like to invite you to see our poster. We did a short study to investigate the added value of using multi-models in defining the possible source region. And for that purpose, we took the advantage of multiple radionuclide data that were available after the Fukushima event. So if you would like to know how an ensemble of atmospheric transport models help in determining the possible source region, then please come to see our poster. Thank you very much.
Good morning, my name is Robin Schoenmaker. I work in CTBTO's International Data Center. I have two posters here to present. This is poster 1. When using isotopic ratio analyses for sample association, we can utilize the possible source region from atmospheric transport modeling to enhance and support this sample association. Not only, and then only looking at the dose level B and C samples that are relevant for decay consistency analysis, and then only dose level C samples in a specific short period of time. And this enables us to discard all other level B samples in that same period of time. And it might enable us to discard those level B samples that are relevant or are disputable, and we can use ATM to see if that's the case to discard them. And on the plot on the right, you see this level B sample with a red cross through it. ATM says you can discard this from your level C episode. That enables us to shift the PSR region. We have a 14-day constraint to do backward analysis for our PSR computations. We can shift it back into the history, back into the past, with 1 week. And for this specific case study, you see that we have this spatio-temporal correlation, also indicating a possible source region at the 15th of January. And we know this because this is a known source for this specific case study. And this flexible and efficient approach might be beneficial for future automation procedures in our end pipeline. Come see this poster on board 16 tomorrow morning. Next slide, please. My second poster is about the radioxenon background issue. It's an issue because CTBT relevant radioxenons pose a problem for our IMS noble gas monitoring stations. Small nuclear test signal in our level B categorization may not be seen due to all these known sources that are stronger. This is a real problem. This problem grows, and we need to improve by means of software solutions and proven methods, scientific methods, and yet to be proven methods to get a better estimation of this background, because this background is there on a daily basis, 24/7. And CBET stands for Xenon Background Estimation Tool. CBET stands for Xenon Background Estimation Tool, and it's just one of a few small projects inside a bigger project portfolio that tries to provide a flag to distinguish between known sources and something else. And this something else can be a nuclear test or an unknown source, or an unknown known source, or a known unknown source. We don't know yet, but if you have a quantifier already, then it helps. And this is on a per sample basis. And we would like to use ATM in this case because ATM can provide residual. And so this project will be discussed on this e-poster also tomorrow morning on board 17. You're welcome. Thank you.
Good morning, everyone. I am going to describe my poster here, and it's not about Xenon Quest. Although, if you're interested in that, you can go to the P&L outreach table. And it's not about WASMIP. It's not an advertisement for WASMIP, which is going to be the week of December 4th in Santiago. What this is about the problems of backgrounds, which you've heard about quite a bit. We need to find ways to mitigate the effect of radioactive xenon backgrounds and other backgrounds on IMS detections. So what me and my collaborators have been doing is doing a few calculations with the assumption that local sources and distant sources may have different vertical distributions. And so we're proposing an experiment, which I hope you can all come to this poster and talk with us about, which is making measurements at more than one altitude away from a source to see, or from several sources, to see if there is a difference in the vertical distributions that can be used to mitigate or determine whether a source that's local could be discriminated from a distant source. So please come and see the poster. I think it's poster number 18, and we can discuss this, and maybe you could get involved if we have an experiment that happens in the future. Thank you.
Good morning, everybody. My name is Judah Fries. I'm here to talk to you about my poster where we looked at the xenon sources. This is through the STAX project of 3 different sources. One is an advanced gas reactor, one is a boiling water reactor, and the other is a medical isotope production plant. So part of what we did was look at the release profiles from each of these sources, and part of what we're going to be talking about in this poster is the implications these release profiles have on understanding detections in the IMS. It's different if you're looking at xenon sources that are looking at average xenon sources versus looking at a profile that directly affected a detection in the IMS. So I look at these 3 different profiles and discuss their impacts on the IMS. Thank you.
Hello, my name is James Ely. I'm from Pacific Northwest National Lab. And on behalf of my colleagues, we're going to present a paper on xenon detection. Radio xenon is important for nuclear explosion monitoring, but is complicated and challenged by benign sources from medical isotope production facilities and nuclear reactors. There are ways to discriminate against these sources, and one of them is the 4 isotope ratio plot. But the question then becomes is how well can you detect these isotopes from a nuclear explosion at distance due to the short half-life of xenon-135 and the low independent yield of xenon-131M. So we've run a number of simulated emissions from a nuclear explosion, and if you have interest in this, please stop by my poster tomorrow, 9 to 10, at station number 20. Thank you.
Good morning, my name is April Carmen. I'm with Pacific Northwest National Laboratory in the United States. The title of my talk, or my poster, is going to be Measuring Explosively Driven Elemental Diffusion in Geological Matrices as Potential Signatures. And I'll be discussing our research looking at using exploding bridge wires as detonation point sources within a variety of geological matrices. We use these detonations to look at migration of elements throughout those matrices. This poster specifically will be looking at granite and looking at iodine and mercury as it migrates through and the differences that we find between those 2 elements. So I'll be at poster number 22. I look forward to speaking to you. Thank you.
Hi everyone, my name is Kiloni. I'm from the University of Texas at Austin. So in this poster, I'm going to be looking at estimating production rates of argon-37 in underground nuclear explosions in various geologies. So argon-37 is a signature of interest for explosion monitoring, and it's produced through the neutron activation of calcium in subsurface rock and soil. And there's some disagreements in the nuclear data about the existence of a thermal cross-section. So with this poster, we're going to look at predicted yields of argon-37 in various geologies, and then also outline an experiment to measure that thermal cross-section. Thank you.
So hello everyone. I am Mohammed al-Bahrawi from Egyptian National Data Center, and today I will present my e-poster, CTBTO Relevant Xenon Isotope Global Background in 10 years. All the collected data by the IMS Noble Gas Stations were used to study the global changes in the xenon background in the period from 2013 to 2022. All the collected data were analyzed, and then we calculated the isotopic ratio between different xenon isotopes and the geographical distribution of the radioxenons actually agree with the geographical distribution of the nuclear facilities. I hope you will visit my poster tomorrow morning. Thank you very much.
Hello, my name is Emily Gordon. I'm from the University of Texas at Austin. This poster is based on a study of complex releases of vented fission products and their signatures at IMS stations. We combined a decay and ingrowth modeling tool in scale with the atmospheric transport modeling tool HighSplit to analyze the effect of varied prompt and delayed venting fractions on signatures reaching IMS stations. If you're interested in hearing more about our methods and results, please come see my poster tomorrow morning. Thank you.
Hello, good morning, everyone. My name is Pranshu Adhikari. I'm from the University of Texas. As we've all heard this week, the current noble gas detection systems for nuclear explosions are based on the detection of radioxenon isotope. This work quantifies the capabilities of a potential hypothetical argon-37 detection network. And we find that there is indeed utility for argon-37 as an additional signature for nuclear explosion monitoring with a sufficiently low detection limit. If you're interested in hearing more, please come visit me tomorrow at 9 p.m. in there. Thank you.
Hi, my name is Lori Metz, and I'm from Pacific Northwest National Laboratory. And throughout the conference so far, we've been hearing how xenon is detected every day by the IMS from background sources such as medical isotope production and nuclear reactors. So the source term analysis of xenon project or STAX project has been working to install high-purity germanium detectors in stacks of partnering nuclear facilities. So then we can measure the xenon right at the source. And then using atmospheric transport modeling, then we can make predictions on what measurements would be made from these backgrounds at the various IMS stations. And then ultimately working on being able to subtract that background source at the stations. So if you want to hear more, come talk to me at my poster or anytime. Come find me and we can talk more about the project and potentially talk about how we can collaborate. Thanks.
Good morning, my name's Matt Goodwin. I work at AWE in the UK. This poster is talking about deploying a small array of radioxenon sensors around the north of England. The sensors are sauna cube systems. You'll no doubt have heard about those this week. And they are measuring environmental radioxenon isotopes in and around the Hartlepool nuclear power reactor. And you can see them on the map here. The work that's going on at Hartlepool is part of the Zena collaboration. It's a multilateral effort, all working with the energy provider EDF. You should go and see Andrew Petts' poster too to learn more about the wider project, but this is focusing on the results of this array of sensors. We've got the STAX system on Hartlepool as well. We've also been doing environmental measurements of samples from the reactor, and we have this network of environmental monitoring. So it's a full suite of equipment that's been deployed to really try and work out what's going on in terms of emissions from a nuclear reactor. Unfortunately, I won't be here tomorrow, but please see my esteemed colleagues who will be happy to talk to you about this poster. Thank you.
Hi, I'm Michael Fox from Pacific Northwest National Laboratory, and I'm going to talk about, we've heard throughout this week about different alternative non-traditional radioxenons that have been observed at SNS and HIFER by Xenon International during testing. And I'll go through looking at some of the different sources that we see and potentially might see as part of the IMS. So with the new systems being more sensitive and additional sources coming online throughout the world, starting to look at what signals we might see both in close and at far distances relative to the IMS. So you can come see my poster at board 29 if you're interested. Thank you.
Hi, I'm Brian Milbrath from Pacific Northwest National Lab. And my poster is about the measurement of argon-39 in shallow subsurface soil. So at previous SNTs, we reported that we had measured argon-39 in the shallow subsurface soil, that's a few meters, above old underground nuclear explosion sites. That's interesting because it implies that you can detect underground nuclear explosions at the surface decades after they occur with this isotope. So in this poster, so we reported on that previously at previous SNTs. In this poster, we report on measurements of the argon-39 background in shallow subsurface soil in areas that are similar in Western United States, but not associated with UNE. So now we're getting the background. And these are the first reported measurements of the argon-39 background in shallow subsurface soil in the literature. And the measurements ranged from atmospheric background to a few times atmospheric background, but much less than we had observed in the underground nuclear explosions. So that's the reason for interest. So if you're interested, please come by my poster, which I think is around 31, if I understand the system. And if you've already played Xenon Quest, you can play the much more selective Argon Quest.
Hello, my name is Tatiana Бойцова. I'm from OSI division, and together with my colleagues from IDC, we have prepared a poster on the possible impact of radioxenon release from spent nuclear fuel reprocessing plants on international monitoring system observations. So in our poster, we first looked at the possible sources of radioxenon in spent nuclear fuel and different parameters that can influence this release. Also, we made preliminary calculations of this radioxenon release during the spent nuclear fuel reprocessing and for several reprocessing facilities. And at the end, we analyzed and discussed the possible impact of radioxenon emission of spent nuclear fuel reprocessing facilities of IMS station and their products. So if you're interested in that, please see our poster tomorrow at 9. Thank you.
Good morning, everyone. I'm Sylvain Topin from CEA France. So we developed at CEA the SPARAX new generation system, which is dedicated to radioxenon detection following a nuclear test. It is especially based on the use of high-resolution beta-gamma system that enable to increase significantly the capacity of detection. And we apply this capacity during 2 qualification periods of the system for integration into the IMS network in Paris and Ottawa that enable to refine our knowledge on radioxenon background. And so please come to my poster. I can present you more deeply our results. Thank you.
So hello, I am Akiko Furuno, a member of Japanese NDC. In this study, we focused on characteristic of cesium-137 detection at JPP33, Okinawa in Japan, from 2012 to 2021. The cesium-137 detection at JPP33 is mostly from winter to spring season and is high concentration correlation with CNP20 based in China. And it is also highly associated with MNP45 in Mongolia from March to May. And it may be caused related to yellow sand, the dust storm phenomenon in East Asia. Thank you.
Good morning, everyone. My name is Daniel Chester. I'm from AWE in the UK, so I'm a member of the Radionuclide National Data Centre and also the GBL15 Radionuclide Laboratory. This work is basically a comparison of some data sets. So we've simulated the conditions within a typical thermal nuclear reactor and also those within an underground nuclear explosion cavity, and determined that it may be possible to determine that a nuclear explosion has occurred, and based on the relative abundances of stable xenon isotopes. And not only that, but importantly, discriminate between explosion cavity gas material and material from a nuclear reactor. Please do come see this tomorrow. I'm stand number 40. Thank you.
Good morning, everyone. My name is Risundari Retnoasi. I'm from Indonesia, and this research is about to give the update of the global radioxenon emission, which is being produced by the molten salt reactor. It's a new technology for the nuclear power plant, and currently there are 7 countries who are progressively to build this molten salt reactor. This radioxenon emission, which is produced by the molten salt reactor, of course, it gives significant impact for the international monitoring system. If you're interested for this topic, kindly come to our poster session tomorrow at 9. Thank you.
Hello, I'm Andrius Puzas from Lithuania, from the Baltic states. I represent actually at this conference. I want to present this time at the SnT, the set of nuclear, certain stations we established currently in regard to the situation in the Belarus and the current situation in the Ukraine for the zero background measurements actually to determine actually the source. And actually we established a very sensitive techniques that work fine together. Actually, we go, for instance, for actinides, we go even down for 1 femtogram per gram concentrations actually for this kind of measurements. And we actually do the international project with Sweden. We have now also negotiations with Poland and Romania to join us, to have, that kind of shield, to know if there are some certain emissions from that, active parts of the Eastern Europe. So, so if you want to know what kind of fallout we determine, actually, please come tomorrow. We have an energetic, determined actually breakfast, and come tomorrow at 9 a.m.
Good morning, everyone. My name is Yana Meresheva, and I work at CTBTO, and I'm here to present our poster with the title Status and Preliminary Analysis of Ongoing Temporary Radioxenon Noble Gas Background Campaign in Japan. Now, the number of our poster is 604. 2 transportable noble gas sauna systems were deployed in Honorobe and Mutsu in Japan and started operating in 2018. Together with the IMS noble gas system in Takasaki, they form a unique mini-network configuration. As of today, a few hundred samples have been collected and measured in Mutsu and Honorobe. Spectra are automatically sent to the IDC and are processed in the non-operational database. Analysis results and raw data are available through the secure web portal. This poster focuses on the status of the ongoing campaign and on operations and maintenance of the 2 transportable systems. We present also preliminary results of the last 2 years. For further discussions, you are welcome at our poster on the board on number 43. Thank you for your attention.
Good morning. First of all, I thank you all for being here in the end of this. I'm not going to keep you very long. There's a few more people coming. My name is Matthias Aldener, and I have a poster about measurements we're doing about the radioactive xenon in the soil, naturally occurring. And if you want to talk about that at length and how that correlates with radon, uranium, transport, water, weather, or how the weather is like in Sweden in the fall or in the spring, rain. It's never really as warm as this. I'll be happy to have everyone over at poster number 44 in the morning. So don't be late. It's going to be a crowd, right? Thank you all.
Okay, hello everyone, good morning. My name is Stan van Leuven. I'm a PhD student working for the Royal Meteorological Institute of Belgium and the Belgian Nuclear Research Center. So yeah, it is well known how noble gases can be used to reconstruct the source of a nuclear explosion. However, nuclear explosions can also produce other radionuclides, some of which attach to aerosol particles. This becomes more complicated since these particles are subject to wet deposition, where rain deposits these on the ground. Correctly interpreting the detection of the leftover particles requires a good knowledge of the wet deposition. So yeah, if you want to know more about how this is dealt with in atmospheric transport modeling, then come visit my poster tomorrow. It should be on screen number 47. Thank you.
Good morning, everyone. I'm Christine Johnson from Pacific Northwest National Lab, and today I'll be talking to you about a novel method we're using to determine essentially gas permeability characteristics of rock that's been damaged by explosions in the underground. So we start with some geophysical measurements, electrical resistivity tomography, and seismic velocity. From those, we then derive the water saturation and porosity of the subsurface. And then we can use this with some large volume nitrogen injections that were conducted at this testbed to determine how well we did on our characterization of these very important gas flow characteristics of the geology. If you're interested, please come see my poster tomorrow morning at 9 a.m. Thanks.
Not yet the right one. Antonietta, do you want? So, as you know, the Xenon International system was tested at Mount Townsend at the location of SnT2023 for the phase 2 testing from July 21 to April 2022. And we performed backward modeling with high split with GFS meteorological data with 0.25 degree resolution. And you see here just one example for a dynamic weather situation where it's quite obvious that the shorter sampling time gives you a more accurate source region as if the wind is turning within the sampling. This may be quite diffusive. But if you come then to the poster or watch it online, you will see that if we combine all these SRS fields, we learn a bit more about potential source regions besides fluorescence, which is the main emitter, and we will proceed in learning from the additional detections of other isotopes than Xenon-133 and the higher sensitivity. And there's also some specialties of the mountain region of Schauinsland, which is challenging for meteorology. So come to screen 52 tomorrow, or meet me as you see me, or just watch it online. Thanks.
Hello, everyone. My name is Munja Mohamed Mahmoud from the Nuclear Regulatory Authority of Mauritania. I'm pleased to present our research on using open source data to make data fusion with the international monitoring system, and that to understand and correlate radionuclide detection. Our work was made in the frame of the cooperation with the Mauritanian data center and Italian data center, in the frame of cooperation with the Bologna University under the contract of VDEC database. So you are welcome to visit my poster tomorrow at 9 at the screen number 50. Thank you.
Hello again, everyone. Christine Johnson, Pacific Northwest National Lab. In this poster, I'll be talking about a unique data set we have of high spatial resolution radon measurements that were collected from a field testbed site, both before and after a series of chemical explosions that were done in the subsurface. And then in particular, I'm going to talk about some modeling that we've done to show how the damage that's created in the subsurface can actually cause that radon to concentrate or deplete in various very hyperlocal regions, despite having a continuous source term throughout the geology. So if you're interested more in this modeling or this data set, please come see me tomorrow morning. Thanks.
Good morning, everyone. My name is Adriana Molero. I'm from Arts Project, and I'm presenting this e-poster together with my colleague, Yuri Starovoit, and in contribution to my ED colleagues from IMS. This is about waveform revalidation process. Sorry to disappoint you, no xenon here. So the revalidation process is undertaken every time a station goes through a change or major upgrade that changes the system response, the data availability of the station. It is triggered by the configuration management board and is led by ED in coordination with IDC and the station operators and contractors that are doing the civil works. So it has usually two phases. First, like the civil work done by contractors, and then the replacement of the software and hardware. The configuration, the validation process is a quality control tool to ensure that the station complies with the technical requirements according to the operational manual. So there are a number of tests that are done with the hardware and the software, so to assure such a compliance. If you want to know more about it or you're curious, please talk to my colleague Yuri or myself, and the e-poster will be available today, not tomorrow, today, from 12:30 onwards on demand. That will be theme 4.1. Thank you.
Good morning, everyone. The objective of my work is to identify the zoonotic situation that contribute the transit of the air masses come from Turkey Point and Laguna Verde nuclear power plants transit across to Cuba. So the progressive trajectory were estimated with the highest split model trajectory. In the result, I found the air masses come from Turkey Point nuclear power plants across to Cuba when the Cuba influenced that with barometric gathering.
Hello, everyone. Good morning. I'm Carlos. I'm from Brazil and from Seaborne Defense Institute. Okay. I would like you to visit my post, board 35, and we can talk about the influence of subtropical anticyclone and monitoring in Latin Caribbean region. Okay. So see you there. Thank you so much.
Hello everybody, I am Gatot Suaryono from Indonesia. My research about Genie version 2 software validation of iodine 131 dispersion from the stack into the environment by using direct and indirect methods. Introduction. This research has validated the Genie version 2 software regarding the characterization of the dispersion of airborne release of iodine 131 from the stack into the environment both directly and indirectly under actual conditions in the field, and estimated the rate of radiation doses quantitatively received by the public. In this case, toddler, adolescent, and adult. The methods or data. Research has been carried out by measuring iodine-131 in the radioisotope production stack inside the house and outside the house directly. Measure with sodium iodine tellurium detector, and indirectly, in this case, air is sampled with a charcoal filter, and the measurement results are calculated with software from Jenny version 2 and estimated dose rates received by the population, in this case, toddler, adolescent, and adult. The result. The result. The data prove that the impact of iodine-131 on the health of organ and thyroid tissue in infant is more vulnerable than in adult and adolescent. The maximum dose, cancer incidence, and cancer fatalities received by the largest thyroid organ and tissue in the Pipeline Village area in the south area of the state. Conclusion. The concentration of iodine-131 activity from the analysis radioactive dispersion from the stack using Jenny version 2 software was closer to the measurement result of the concentration of activity of iodine-131 with the direct measurement method. Mean regression is 0.95. Then the activity concentration of iodine-131 with indirect measurement regression is 0.93. Thank you.